All right, I'm going to walk around, team. Thank you very much for having me. So I want to introduce you to a future. In fact, this future is here now, and I've already chatted to a couple of people in the room. They've actually got the tools that I'm going to talk about here today. So imagine a future that gives you warning time. Warning that something bad is going to happen, okay? So maintenance is equal to safety in our language. Me being in reliability, there's certain things that can happen when things break that put our people at risk. A failed haul truck isn't just downtime, it's danger, okay? The maintenance conversation has shifted from uptime to safety uptime. And I'm a big fan of Ron Moore, and he says, I don't know if does anyone know Ron Moore? Have anyone heard of Ron Moore? He's like an international speaker on reliability, okay? And Trevor mentioned my book there earlier. He actually reviewed my book, and if you meet me down at the NB Industries, I've got some books there to give away. A reliable plan is a safe plan, and he's actually done some data on this. Total injuries per year versus corrective and reactive work orders, okay? There is a 0.83% correlation between that. Okay, so if we get reliability and maintenance right, we're going to have a safer plant. There's the data to show it. A reliable plant is a safe plan. Small faults, big consequences. Most catastrophic failures begin with something small. A partially blocked filter, a dusty air induction leak. Okay, take note of that. I'm going to talk about this in a little bit more detail in a second. Equipment doesn't fail, it actually deteriorates. It generally gives some symptoms, okay, some symptoms that it's going to fail, okay? This one here, I don't know if you know this one, but we had a right-hand side spindle failure on a Cat 797. And again, it comes back to the point that most catastrophic failures begin with something small. It's just a small crack, okay? And it led to this here. True story, by the way. I found that in an academic paper. Traditional maintenance falls short. Most catastrophic failures begins with something small. Reactive, it's too late. So if you're fixing the equipment on the run, you're too late. The bull has already broken the gates. Time-based, often is too often, or we're doing it too much or too little. We miss stuff, okay? Both approaches miss the early warnings, okay? And that's what this is all about, is giving you good people time to react to a problem. Time to react to a problem. I think Maverick said time is your greatest enemy in Top Gun. So we want that time. We need something smarter and more than just inspections, okay? So with preventative maintenance these days, what has changed? And there's a few, let's call it buzz things that I'm about to mention. Sensors and IoT, obviously we've got equipment now that is more electronic than what it ever has been, okay? We can get all sorts of data off these pieces of equipment, and that's one source of where we can get the symptoms from. Machine learning, I'm going to talk about this a little bit more in detail here in this presentation, detects deviations from normal, okay? Imagine training someone that sits there 24/7, 7 days a week, 365 days in a year. You don't have to feed them. And they're constantly monitoring and looking for abnormal behaviour on your equipment. I'm going to give you some insights into how this actually works. Dashboards and alerts, okay, real time, actionable data. We need that because we've got to do something about it. And then closed loop feedback. And it says here, systems that automatically act when the risk is detected. And yes, have we got some people around the world actually doing that? Yes, we do. Okay? So they're hooking AI, and their AI is actually controlling their plant. Okay? Very interesting. How it actually works. I'm not a data scientist. I'm a reliability engineer, as Trevor said. I have built these little green dudes. These little green dudes with the antennas out of their heads are an algorithm. They're a mathematical algorithm, commonly known as machine learning. Okay? And what my little bot can do is he can take a tag. A tag is a data stream. He can take that tag and he can learn what normal looks like. You can see there he's got the little green tick. He knows what that actually looks like as normal. All right? Not only can he take one tag, he can actually take multiple at the same time, and he can actually take 1,000 plus tags. Okay, 1,000 plus data streams, do calculations on that every second and tell you whether the behaviour of that equipment is normal or abnormal. 1,000 plus tags. To my knowledge, there is no limitation. It's just how much compute you put against it, and the IT guys can sort that out. Okay? So, what he can also do is he can actually find where the behaviour deviates from normal, or what the IT people call abnormalist behaviour or abnormal behaviour to us real people. Okay? He can identify what is abnormal, and you can see there in the red shaded zones, he's identified the little pimples. Okay? And he can say tag number 2 is bad, and here's the areas where it is bad. Okay? He can do that on 1,000 plus tags every second. Right? So we've got a lot of supervisory power. In fact, this little green dude, we actually call the supervisor. So down at my stand, I've actually got a whole engine running, and I've got a supervisor there monitoring an engine. Okay? And we can induce a fault and see what happens. Has everyone got that? Can I move on? Okay, I want to get to something real now. A Caterpillar 797, okay, one of the biggest cat trucks that people make. And so what we did was we took some engine data from this 797. Not a data scientist, as the reliability engineer, trained up my supervisor. Okay, I called him a 797 engine supervisor. Righto? Now, this particular truck had a loose hose clamp on the intake manifold, on one of the intake manifolds on the V16. Righto? It occurred where the big red arrow is. Righto? Now, I've highlighted 2 zones here, two red zones. One red zone is where they shut the machine down. And you can see here that my algorithm is saying that's abnormal behaviour compared to the rest. It is, isn't it? Wouldn't you agree? Okay, so he's picking that up. That's abnormal behaviour, okay, in this case. But he's also picked up this little spiky bit here. That little spiky bit there is where they actually had an EGT alarm on the 5th of June at 5:15 in the afternoon. Truth be told, if this little guy was on the truck supervising this truck, he would have found that 6 hours before the actual cat alarm. That's plenty of time to get in the spare. Okay, and we're not dealing with an EGT alarm in the middle of the pit mid-circuit during a production cycle. All right? Now, how did this guy figure this out? Let's zoom in. I'll help if I press the right button. Let's zoom in and have a look at what he's actually seeing. So I've zoomed in here and we've got a green, a red and a green zone. Now, I'm sure as humans, you can see the difference in the pattern in the data. The 2 green bits look different to the red bit, and that's what our algorithm is picking up on. Okay? And he's picking up on, and if you have a look at the time scale there, okay, you can see where the 6 hours has actually come in. So he's actually predicting this alarm 6 hours before. Now, how do we know that he's actually getting it right? Because he actually tells us. And hopefully you good people can see this. The big blue bar represents what is behaving the most differently, and if you read the top line there, it's the left to right exhaust gas differential temperature. So our little bot is telling us 6 hours beforehand that you're going to have an EGT alarm. Okay? That's how this technology works. Now, where else has it been applied? That's one that I did. Here's some stuff that other people have done. See, these are on 282s, and you'll see here before, during, and after. And that is just using data that the truck collects naturally. There is no extra sensors or anything like that on the 282. And the person that did this, and again, another fellow reliability engineer, did this with no code, and he was smart enough to actually train our little bot on the ambient air temperature. Okay, so we combined the ambient air temperature with the bearing temperatures, and what the bot picked up on was the subtle rise in temperature of these wheel bearings. Now, how do we know that the bot got it right? Because they pulled the machine apart and found that the bearings were actually well and truly failed. Okay? And then they put the machine back together, started running again, and our bot says it's all gone back to normal. Okay? Everyone see that? Cool, cool. We're not just limited, or these guys are not limited to just machine data. This again is on 797s, and we got our little blue dude. I'll explain the little blue dude here in a second. He is called the lackey, all right? Because all he does, this little guy here, all he does is he identifies wheel bearing failures on 797s from oil samples. So that's why that data up the top there looks a little bit funky, okay? You can see his response here. The difference between the supervisor and the lackey is that you've got to tell him when the failure has occurred, okay? So some people call it a failure mode, okay? So you train him specifically on this failure mode. So what this little guy does is as soon as your oil samples come out from ALS or whoever your service provider is, he reads that data and he assesses whether you've got an impending wheel bearing failure on a 797. Now, I'm told that detecting wheel bearing failures on a 797 is quite an art, and that's why the site trained this guy up, okay? So we call him the lackey. He only looks for one thing. Cool, cool? All right. So having 18 days of lead time from our lucky, okay, smarter scheduling, safer teams, okay, dare I say it, we can also have more available equipment, okay? It's not just check, it's a culture, okay? It shifts teams from firefighting to planned work. So we have fewer call-outs because we know what's happening, fewer surprises, and fewer high-risk, high-stress repairs. I've been there in my corporate life as a corporate reliability engineer. I had a CEO one time come down and I was a maintenance manager, and I said, "Would you like to see a failed plant, Terry?" And he said, "Seven, I trust you have it under control." And I went, "Oh shit." Okay? So I've been there in the high risk, high stress repairs, and having these guys at the time, as in the supervisor and the lackey, would have helped me out in that case. All right, what can we detect? There's all sorts of things that we can detect. The key point here is that we actually have the data to do it. So if you can see the abnormal behaviour in the data, okay, these guys can actually find it. Okay, so dust in the engine, airflow, hydraulic spikes, flow monitoring on your diggers, chassis fatigue, strut pressures. If you come and see me, I've actually got a strut pressure one actually running live down at the stand. So please, I can show you that if you're interested in that. And I know that chassis life is a conversation that people are having, and we're trying to push chassis lives around out to 100,000 hours on our haul trucks, and people are not succeeding in doing that. Okay? Now, operator trust. Our operator operators and our maintainers have to trust what these guys are saying. Otherwise it doesn't work. Who's ignored alarms? Okay, that's what I'm talking about. These guys have a method of communicating. Alarms is one method. Now, to build that operator trust and the sites in these little guys, I would argue, okay, that if you want these guys to overlook your machines, I would suggest that your site guys actually build them yourselves. You do not need to be a coder, and I can show you how to do that. Visit me down at the stand and we'll build one together. Okay? When they trust these guys, the advantage is gained. They can act early. If they've built them, they trust them, and they move forward on what they recommend, and they can see what's simply going on. There's less second guessing, and better alert response and safer decisions. As I said, the supervisor there earlier gave you 6 hours warning, okay? We can make a safer decision on site as a result of this, okay? Now, I'm going to throw this one out here. It might be a little bit controversial in Queensland, especially in New South Wales as well, especially critical in autonomous fleets. No humans on your haul trucks. No humans to listen for the squeak, the bang, the rattle, the knock. These guys can see that. And as I said, these little guys are DIY, you do it yourself in 15 minutes. The little green guy is literally 15 minutes to build in 4 clicks. All right? So return on investment that goes beyond cost. Yes, predictive stuff saves you money, fuel parts, fuel breakdowns, etc., because you've got the heads up about that. Well, what's the true ROI? Obviously safer people, because we're not putting them at risk dealing in unplanned failure. Okay, we have more predictable operations. We can schedule stuff in. Okay, and dare I say it, less fatigue and higher morale because we're in control. How to get started with this stuff? It's 8 simple steps. Pick an asset, audit what you already have, let the tool clean the data, train a model, 15 minutes, configure your dashboards, monitor feedback, scale to other systems, and then most importantly, continuous improve. Again, you're in control of the little green and the blue dudes, okay? You can make them better. As you learn, they learn because you are in control of them. All right? So maintenance just isn't a cost, it's just one of your strongest safety tools. Predictive systems do not replace teams, they empower them. Imagine having someone 24/7 watching what's going on. Okay? With bots, safe, intelligent maintenance is operational today, not an aspirational tomorrow. I can show you today, down at the stand, how these guys work. That's me done. Thank you very much, team, for attending this. I think I've got question time. Is it question time?
Thank you. You've got a couple of minutes if anyone's got a couple of quick questions for